Hey everybody, welcome back to a part 4, can't believe it, part 4 in our series on object-oriented programming. The video I have been waiting to make, probably since I started making these YouTube videos, interfaces and polymorphism. And why have I been waiting all this time to make this video? Because I didn't understand interfaces. And now I love interfaces. First time, and I'm going to get into the code real quick, but so just right, like this is normal. And so when I first kind of discovered like this is what an interface was, found documentation, like it would, like that was kind of simple. Okay, I see like how this works, but I couldn't understand the why of it. Why would I want to use an interface? And that really comes down to polymorphism, but I didn't understand this big, object-oriented $10 buzzword of polymorphism. So what I really want this video, when you understand how awesome interfaces are, how awesome polymorphism is, you understand that this is a learning process, and we're going to try to kind of start to develop some stuff that might actually be slightly useful or something kind of like what you do in the real world versus creating a list of animals or a list of cars, which, call me, but typically my everyday life in enterprise software development never involves iterating over lists of animals, even though it does help drive home points for YouTube videos. All right, so let's go over and let's just take a look at the internet. What does some other guy on the internet have to say about it? And again, I've kind of liked these Stackify definitions, so we'll keep on using them. But all polymorphism is, and this is what we'll understand hopefully in this video, is it lets an object have more than one type. At a high level, so if you could think of in Salesforce, right, you have your S object, account, and opportunity, and lead, and contact. They're polymorphic. They are all S objects. So they are of a type of account and a type of S object, for example. And we're gonna show what this looks like in just kind of idiomatic Apex. And we're also going to try to explore a couple real fundamental programming concepts. We're going to talk about what does it mean when your code is tightly coupled versus loosely coupled, and how interfaces help us achieve that loose coupling. And we're going to talk about, again, you're going to hear people say program to an interface, not an implementation. So we're going to see what all of that stuff looks like. So I'm really hoping this is a useful video. I wrote some of the code ahead of time, because I thought maybe it just might be, so I wrote maybe kind of the bad implementation first, and then we'll get into the good implementation, right? So let's, enough said, let's get into, let's open up our illuminated cloud, right? All right, so let's start off. So we have a discount calculator class. And our story, our use case here, the business wants to, right, like there's a standard discount that we apply to all our opportunities. Everybody that buys anything, they get this standard discount, right? So we have a discount calculator, right? And this remember, a constructor takes an opportunity, and it takes an object of the type standard discount. And then it has a discount opportunity method. I'm going to change that name to discount opportunity. And then so let's open up standard discount, right? All it's taking is the amount, the opportunity amount. It's applying a discount. In this case, we just hard-coded in a value of 0.05. We could get that out of custom metadata or something just as easily. And it returns the discounted opportunity value. So then, I don't know, maybe like in this case, for the sake of this video, we're not going to do any DML. We're not really going to update our opportunity. We are just going to return the new opportunity value. So we got our class, takes an opportunity, takes an object of the type standard discount, calls standard discount, calls the calculate discount method, and gets the discounted opportunity amount. So let's run a test, right? And I just changed that name. So discount opportunity. We're going to compile that. And so, right, if we did everything right, let's run our test, right? That should equal, we're giving it an amount with an opportunity of $500. Our test passed. Close that out. And that's what we expect, right? That our new value was 475. So it's all working right. But So it's good. Our code works. Our code does what we want. I mean, and it's not bad, right? But we know change is constant. So let's go back to our discount calculator class. So 6 months from now, 3 weeks later, the business, hey, great job implementing this discount procedure. You know what? We would now like to have a small discount and a big discount. And those are going to depend on the size of the opportunity. Can you do that for us? And so let's talk. So I've already written, right? These classes, there's no logic in them. We've got a small discount and a big discount class. But now, so you can see here, so here's the challenge. We have our discount calculator is tightly coupled to the standard discount object. It is coding, remember earlier, so it's tightly coupled. It is creating it's using a new standard discount, and it's programmed, we'll call directly to the implementation, right? It knows, we kind of have a knowledge in this of how the standard discount class works, which is not what we want, right? So let's say, in fact, in this case, I just passed it to the opportunity, but, so to make it even more, let's make it even more tightly coupled, right? We could just, so let's say we had something like this. This dot standard discount equals new standard discount. And that's probably even a better example to show, because especially anytime you see the word new in your programming, I always say, like, sometimes the good thing to keep in mind is the word new is glue. If you have new, there's a tight coupling going on. Your code is, the discount calculator class is dependent on the standard discount calculator class. And the odds are, if we make changes to standard discount, it's going to affect discount calculator. So we don't really want this. This is not like, as you saw, we ran the test worked, but it's really not the ideal way to do this. And it's not very flexible. And this is where interfaces come to the rescue. So let's create an interface. First off, Apex class. We'll make it an interface, and we're going to call it iDiscount. So first off, I'm going to start off with, I tend to name my interfaces starting with the letter I. You'll see that a lot as a common programming convention. It's not required. See what your team likes to do. For a while, I didn't do it because Bob Martin in Clean Code does not like to start interfaces with the letter I. But somewhere along the way in my own professional life, I realized that my own personal preference was to begin my interface class names with the letter I. So we have, an interface, right? So again, it's a type of object, and we're going to give it, interfaces contain methods. So we'll say public, and we're going to want an interface that returns a decimal. And in fact, we don't need public because interfaces are public decimal. Calculate discount. And it's going to take a decimal. How about I spell opportunity correctly? Opportunity amount. And semicolon. We have an interface. And this is what an interface is. An interface contains methods that have no method body, just the declaration. So we have a method named calculate discount, returns a decimal, and it takes a decimal. But there is no, there's no curly braces and, do this stuff. There's nothing in there saying how do we actually calculate a discount. This is it. It's a method with no implementation to it, right? Okay, so let me get rid of this stuff. So this is me. The first time I was like, right? Like, what's the point? Why on earth would I want to have a method without any logic in it? Just a method declaration, right? This is the most pointless thing I have ever seen. That's how I felt. I Googled it and I tried to watch videos, and there was nothing I found that really made sense to me until maybe I started to learn more about design patterns and polymorphism. So All right, so let's say here's where this comes into play. All right, so first of all, let's go back to our standard discount class. And anytime we use an interface and we want to make use of it in other places, implements iDiscount. So we use implement. So we say that the standard discount class is now going to implement the discount iDiscount interface, right? Which is, as you would know, already contained that method signature of calculate discount. So there's nothing else we really need to do here. All right, so standard discount implements iDiscount. And you've seen, if you've written Queuable Apex or, schedule, right? You've seen the implements keyword before. So anytime you implement an interface, you must implement, what that means is you must implement those methods. So if we had, if we had something else in here, set update discount or whatever methods we list here in this discount in the interface must be implemented in any class, any object that's going to use the interface. So if we let's go back to our big discount. We're going to say big discount implements iDiscount. And, this is nice. This is Illuminated Cloud doing this for me. Throws a big red line underneath that for me. So let's hover over it. And it says, hey, right, this isn't even going to compile because you must implement the following method, calculate discount. So I'm just going to go beauty of using, if I can figure out how to do it with my, right? So we, beauty of a good editor. I'm just going to say, okay, implement the calculate discount method. And I am going to copy and paste right out of my standard discount. Control C. Big discount, and so we're going to say this one. Why is it not copying? So let's do it this way. Sorry about that, everybody. All right, and now let's say, so our big discount, let's say that's a 10%. That's a 10% discount. All right, and now, right, if I try to compile this, it's going to compile. So our big discount, all we're saying is this class, you know what, because that's in there. So we're going to say amount. We'll do it that way. This will compile now. So we'll say that because I am tongue-tied, and I apologize for that. So big discount and standard discount, right? They both implement calculate discount, and so they both have the method, but they implement it in different ways, right? So, and I'm going to change that to, I'm just going to change my method signature real quick. And compile that one up too. All right, so let's do our small discount. So now, implements iDiscount. And we're going to paste in. And we'll say our small discount. So in this same class, all three are how about I put that inside a, I'll put that inside the, inside a method signature, right? All right, so now, right, all three of these discount classes, small, medium, and standard, or big, small, and standard, all implement the iDiscount class. They all have, so that means they all must make use of the calculate discount method, but they all have their own separate implementation of calculate discount method. But this is where it gets cool. So maybe I'm going to just open up Anonymous Apex. Let's get rid of our coffee drinker stuff from our last video. Get rid of that. And so let's just say iDiscount standard equals new standard discount. And let's say iDiscount big equals new big discount. And iDiscount small equals new small discount. So this, bring this up maybe into the center of the screen a little bit. This is polymorphism. Okay, so we have 3 different objects here. You can see we have a new standard discount, big discount, small discount. We have instances of 3 different objects, but all of them can belong to the iDiscount type. So this is polymorphism. This is where it really starts to get cool and where it starts to get very useful in our programming. So again, 3 different objects all sharing the same type, and they all contain different implementations of the calculate discount method. So if we go back to our discount calculator, which if we remember was tightly coupled to the standard discount class, let's get rid of that. So we're gonna, I don't want that in there anymore. Get rid of that. Get rid of that, and I'm gonna get rid of all of that stuff. So let's do, instead of taking a standard discount, what we're going to do is say, hey, this is going to get a type of iDiscount. Discount. And then, so what that means is we could now pass in a small standard or a large discount. Whatever we needed at runtime could be supplied to the discount calculator class. We're no longer tightly coupled to the implementation of standard discount. We can make use of any class that implements the iDiscount interface, right? So now we would just have to say decimal result equals discount dot. So because we know from our interface the iDiscount interface, requires the calculate discount method, right? That is in the contract of implementing that interface, is that you must implement that method. We know that anything that gets passed in of type iDiscount will contain a calculate discount method. So let's just say, and then we need our and so then let's just return the result. All right, return result. And we're going to compile that. Let's take a look at our test again. Let's see what we can do. All right, open up our discount calculator test. And remember, we changed our constructor. So let's say I'm going to do what do we want to do? Let's pass in a big, so this should fail. If we pass in a big discount and this works, like this should fail, right? So let's say iDiscount, because that was a 10% discount. New big discount. Let's pass that in. Big. Did I put that in the constructor? All right, for now we'll put it in the constructor. And we'll show you how to, after we do this, we'll show how to use a factory method to handle it that way. Discount. No, this dot discount equals discount. All right. Let's go back to our test and let's run it. If we did it right, it should fail, right? In fact, you know what? Let's just, yeah, we don't need a debug because we got an assertion there. Let's run it. All right, so boom, that failed. Let's scroll down to our assertion. And that's the failure we expected, right? Instead, we expected 475 for standard discount, which remember was 5%. But remember, our big discount implementation was 10%. So the calculation was, we introduced this flexibility now to be able to pass in multiple kinds of, I'm going to just change that name. I'm just going to update this one. but to multiple types of discounts. So our discount calculator class has much more flexibility. It's not dependent on the standard discount class. Any class that implements iDiscount will now work with it. So let's say new, and I'm just gonna set this one back up. And standard. But even better, so now what we really want to do is we've got this. So right now, we're passing it in the constructor. This is one way to do it, which would work, and you could implement this at runtime. Another way that I really like to do this is through a really simple factory. So let's just we're going to open up a class, and we're going to call it our discount factory. All right, discount factory. And we're going to give it a public, in this case, and I usually make these a static method. Static can be lowercase. Public static. And it's going to return an iDiscount. Get discount. And so let's say now decimal opportunity amount. Okay. All right, so we're back in here and we're working on our factory method, right? So we're going to use this factory method to return the appropriate discount at runtime. So we have our get discount method, which takes a decimal of amount. And in this case, we're going to just use an if statement. Originally, I was thinking of a switch statement, but you can't use a switch statement with a decimal. So we'll just say if, all right, and if amount is greater than or equal to 1,000. And we're going to say, if that's the case, return new big discount. Then we'll say else if amount is greater than or equal to 500. Should make this up here. I'm just going to hop in there and make that a decimal real quick. All right, we'll say return new standard discount. And then we'll just say otherwise else return new small discount. All right, compile that. So now we have this little factory class, right? So we can go back to our discount calculator, and we can say this dot discount. I'm going to say equals discount factory dot get discount, and we're going to pass in p dot amount, right? So now, if we did all this correctly, if we go back to our test, make sure oh, we don't need that. We took that out of the constructor, right? Because we're getting it from the factory method. And let's run our test. There, it passed. So just to prove it again, tell you what, we'll do another one. I'm gonna copy and paste all of this. Control C, Control, why? Someday I'll get used to the Mac keyboard. All right, let's do that again. Let's do this all again. This has been a rocky video. Thanks for if you are still here, thank you. Copy. All right. Paste. Let's test. Change that to big discount. And we'll make our opportunity $1,000. So that's a 10% discount. So this should equal 900. But right, we didn't have to change anything about our, we don't need that anymore because we're not instantiating it there. We didn't have to change anything in our discount calculator class, right, to make use of any of this. So if later on the business wanted to add a super big or an extra small or whatever type of discount you might have, I mean, yeah, so you would need to create a new class that implements the iDiscount interface. And you would need to update, in this case, your factory pattern. I'll show you in another video how we could even do that with something like custom metadata, and we would never even touch that class again. But I feel like this one is getting long enough already. So I'm hoping, there we go, our test passed. I'm not going to write one on the small because I think we see like it's going to pass, right? All right, so again, let's run through this. We got an interface. All interfaces contain our method signatures, no method body, no implementation of method. So you're like, this is me a couple years ago. What's the point? Why would I ever want to do that? Because now my discount calculator class is no longer tightly coupled to standard, medium, small, super big. I don't care. I just need a discount. And I know that whatever I get back, if it is of type iDiscount, boom, it is going to have the calculate discount method. So I just have to call my factory class because I know that, and I know my factory, right, is going to return something of type iDiscount. So I know so that means I know whatever it returns, I can call this method and I can expect to get a decimal back. So that is interfaces, that is polymorphism. I really hope this helped. If it did, take a second, hit thumbs up, hit subscribe. Really hope this is a good video. Please give me some feedback in the comments. Let me know what you thought, and I'll see you in the next one. Keep practicing, keep on getting better.